Show that the product of two odd integers is an odd integer. So it's something like this. It's a quite a simple proof. You don't need to write too much, but remember, what do we do? We need to something that's going to guarantee that we have two odd integers. So we need to define these two odd integers. So if we call them m, so let m and n be our two odd integers. Okay, so they are going to be our two odd integers. Now we need to have a kind of a rule for them which guarantees that they are odd integers. Now if you remember back in previous videos, I told you to, if you ask for any odd number, then you could use like a 2n minus 1, a 2n plus 1, a 2k minus 1, a 2k plus 1, something like that. So if we say, we'll say let m equal 2r plus 1 for some integer r. So r needs to be an integer. So what that means is any integer, if we times it by 2 and plus 1, you guarantee that the result will be odd. So that's telling us that m is an odd integer if r is an integer. Right, so we'll do the same, something very similar with n. So let n equal, but we won't call it 2r plus 1, we'll need a different letter. So 2s plus 1 for s also needs to be an integer. Now, the reason why we need it to be a different letter, if we used r again, you're only really proving that it works for the case when m equals n. And yes, that is one case that it needs to work for, but it also needs to work for any odd integer. So when they're equal and not equal, which will be most of the time. Right, so now, if we just write the product, so mn is the product, m times n, well that's going to be 2r plus 1 times 2s plus 1. So if we just expand that, that would be 4rs plus 2r plus 2s plus 1, right? So now the way we need to show that this is odd, an odd integer. So if you think of the way we started off with our odd integers, if it's 2 times an integer plus 1, or 2 times an integer minus 1, or plus or minus any odd number basically, but plus 1s would be nice because that's how we define them in the first place. We can express this in that kind of form, then it shows that it is odd. So if you look at these first three terms, they've got a common factor of 2 in there. So let's just pull that out. So equals 2, and so that would be 2rs plus, and then you've got r plus s. I will leave the 1 out, the plus 1, right? So then, if you think about it, we know that r is an integer, s is an integer. So this is 2 times an integer times an integer. This must be an integer. This must also be an integer. So everything is here. So this is integer. So this whole thing must be 2 times an integer plus 1, which must be odd. Well, this is of the form this is of the form 2k plus 1, or 2 something plus 1, but we can't use r or s or m or n. 2k plus 1, where k is an integer, and so hence therefore the product is odd. Okay, so that is enough for a direct proof in this case.